permutations. And the last permutation we did is we had 7 cats finishing a race. So we assumed that all 7 cats finished. Now I want to rephrase the question. I want to say, suppose I have 7 cats. In how many ways can I find first, second, and third place? So I had 7 and I only want to select 3 to finish. That's a different calculation. And that is called a permutation when our objects are selected from n. And this is our formula. Now, I'm going to do one by hand, just so that you see what this means. And then we are going to do the rest of them on our calculator. Okay? All right. So I'm going to use the example that I just used. All right. And it's called the trifecta. It's when you select the first, second, and third place finisher. So when you're betting, when you bet the trifecta, you're trying to select the 3 people that come in first, second, and third. And here we have 7 entries. And if you want to guarantee a win, how many tickets do you have to win? Have to purchase. So the question is 7 entries, select 3, and order matters because it's a race, right? In a race, it matters in what order you finish. Otherwise, it wouldn't be a race. So in math notation, that would look like 7p3. 7, pick 3, and permutation order matters. Now, according to this formula says that this is 7 factorial divided by 7 minus 3 factorial. Okay. Well, last time I checked, 7 minus 3 is 4, right? Okay. So 7 factorial divided by 4 factorial. Well, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Oh, I notice there's some canceling going on here, right? 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1 is 1. So all I'm left with is 7 times 6 times 5, which is 210. Okay? So that's if you have to do this by hand. Now, come on. We are not doing this by hand, right? That's why we have one of these. Okay, so if I want to calculate 7p3, the first thing I'm going to enter on my window is the 7, right? The 7 comes first. Now I need the P. To get the P, go to Math, Probability, and look at what number 2 says. All right, number 2. So now we have the 7P, and now enter 3, and hit enter. And sure enough, what do we get? 7P3 is 210. Okay, so I'm using the math button, which is right there. Okay, 7p3, 210. Okay, so from here on out, I'm going to be doing all of my calculations on my calculator. I will not be wasting our time doing this by hand. Yeah, it's great, but we have technology. We use it, right? We have cell phones, so we don't use rotary phones anymore. Okay, now, the last example I did, order mattered because we were talking about a race. However, order doesn't always have to matter. This thing called a combination is a group of objects without regard to their arrangement. So, for example, if I go to the pet store and there's 20 cats and I just want to buy 3, it doesn't matter in which order I grab the 3, right? Because I'm just grabbing 3 cats, right? 20, choose 3. Now, so in that case, instead of a permutation, I'm going to use a combination. The formula changes a little, but I don't care about this formula because what do you think I'm going to be using to do my combinations, right? I'm going to be using my calculator, okay? So remember, permutations, order matters. Combinations, order does not matter. Okay, So let's do a combination. How many different 5-card poker hands are there using a standard deck of 52 cards? Now, when you're playing poker and you're dealt the 5 cards, it doesn't matter in what order they get dealt to you, because the first thing you do is shuffle them in your hand, right? So in this case, I don't care about order. I need a combination. Well, I have 52 cards, a combination, and I want to choose 5, right? 52C5. Now, I could go through this formula. Oh, it's not going to be pretty. Okay, we're going to be here all day. That's what this is for. All right. So again, it's 52C5. So I'm going to type in 52, math, and I'm going to go to probability. Oh, look at number 3, right? C. So I want 52, and I want combinations 5 at a time, right? I got 52 card deck. I want to pick a 5-card hand. There are that many 5-card hands that you could be dealt in poker. Okay? So that is 2,598,960 hands. Okay? All right. So permutation order matters. Combinations order does not matter. Okay, so we've gone over 3 different principles. Let me give you a summary. And this is what you really want to use. If you're working on a problem and repetition is allowed, then you're going to use the fundamental counting principle. Okay? Because when we're doing combinations and permutations, we're not allowing repetitions, right? When you're running a race, can the same person come in first and second? No, right? If I'm doing a 52 card hands and I'm doing, poker, can you be dealt, 2 ace of spades? No, that's not how it works. So if you see repetition, so this is going to be ATM codes, license plates, things like that, we're going to be using fundamental counting principle and draw your slots. If your items can't be repeated and order is important, use permutations. The words you're looking for are things like arrangements, order, race, right? Once you say race, order matters. Okay? If the selected items cannot be repeated or an order is not important, so we're talking about a group, so you have 15 people, pick 3 to be on a committee, doesn't matter what order they're in, it's combinations. Keywords there are going to be set, subsets, groups, samples, selection, just a group. Okay? All right. On the next video, we're going to do a whole lot of examples. Okay? And I have them all mixed up, just like your homework.